NASA is about to bet 4 human lives on a machine that has never once worked the way it needs to. And the wild part is, nobody knows yet if it can be made to work in time. That machine is bigger than any single rocket. It is the entire tangled web of hardware that has to come together for Artemis III, and it is the thing that quietly decides whether humans walk on the moon this decade or not. So, almost everything you think you know about this mission is already out of date. It was supposed to be the landing. It is not anymore. NASA changed the plan, changed what the flight is even for, and most people have not caught up. So this is everything you actually need to know about Artemis III in one place, and why the real story here is a gamble that has almost nothing to do with the landing everyone is picturing. And the crew NASA named on June 9th, 2026 tells you what kind of mission this really is. These are test pilots and systems people, the kind you assemble to wring out a machine that has never flown end to end. Commanding is Randy Bresnik, a veteran Marine test pilot and former space station commander who spent years working inside Artemis development itself on Orion, SLS, the landers, and the suits. His pilot is Luca Parmitano, an Italian from the European Space Agency who has commanded the space station, once kept his head as water flooded his helmet mid-spacewalk, and is the first European ever assigned to an Artemis crew. The 2 mission specialists carry the theme further. Frank Rubio holds the U.S. record for the longest single spaceflight at 371 days, so he knows what happens when a mission stops following its plan, and Andre Douglas, an engineer who backed up Artemis II, bridges the flight that proved Orion and the one that has to prove Orion can dock. Bob Hines, a commercial crew test pilot, is their backup. Let us start with the rule, the way going to the moon used to work. Apollo looked simple from an architecture point of view. 1 Saturn V, 1 command module, 1 lunar lander, all built around one government-led landing plan with one tightly controlled mission architecture. If something did not fit, the program could force the pieces to work together. The whole moonshot moved like one machine with one owner. Artemis broke that rule completely. It is deliberately stitched together from pieces that different companies and countries build separately. The Orion capsule comes from NASA, Lockheed, and Europe. The rocket is NASA's own SLS. The landers are commercial machines from SpaceX and Blue Origin. The suits come from a company called Axiom. Every one of those is a world-class piece of engineering on its own. The problem is that none of them grew up together. And here is the break that creates. In Apollo, the danger was a part failing. In Artemis, the danger is the parts not trusting each other. You can build a flawless capsule and a flawless lander and still lose the mission if the 2 of them cannot talk, line up, and lock together in space. That seam between systems is the single most dangerous spot in the entire program. And it has never been tested with people on board. That is what Artemis III actually is. The seam itself is the mission. Let me put the scale of that risk in plain terms. Picture 2 vehicles built by different teams, designed around common interfaces, both moving around Earth at 17,000 miles an hour, trying to merge into one connected spacecraft while the crew depends on the connection holding. That is rendezvous and docking in orbit. Now, imagine the first time you ever attempt that full system for real. You do it 3 days travel from Earth in lunar orbit. If something jams there, every backup option becomes slower, harder, and more dangerous. So NASA made a call. Run that first attempt where the crew can get home much faster if something goes wrong, long before anyone tries it 3 days out at the moon. That is why Artemis III is now a low Earth orbit mission. 4 astronauts launch on SLS from Kennedy Space Center in 2027, climb into orbit, and rehearse the dangerous handshake right there, close to home. They will chase down test versions of the commercial landers and practice docking with one or both of them, while engineers watch every interface and line of software for the places it almost breaks. Artemis II got to loop the moon. This crew stays in low orbit on purpose. The actual South Pole landing got pushed to Artemis IV, now aimed at 2028. So visually, Artemis III will not look like the mission people expected. There is no lunar flyby, no descent to the South Pole, and no astronauts stepping onto gray dust. The drama happens in orbit over Earth. Orion has to launch, check out its systems, find the lander test vehicle, approach it safely, dock, verify the connection, test the communication links, prove the crew can work through the procedures, then separate and come home. It sounds less cinematic than a moon landing, but it may be the test that decides whether the moon landing can happen at all. So the order is simple. Artemis II already proved Orion can fly humans around the moon and home. Artemis III has to prove Orion can connect with the landers that go down to the surface before Artemis IV rides that whole stack to the lunar South Pole. And here is the detail that should make you raise an eyebrow. Those four are already training on test versions of the landers, some of which are not finished being built yet. Read NASA's own wording carefully, and you will notice they say Artemis III will dock with test versions of one or both commercial landers. One or both? That little phrase is hiding the real uncertainty in this entire program, because the mission does not fully know yet which lander it is testing. It depends on who is ready. SpaceX is building a moon version of Starship, and NASA has already been rehearsing with it. Back in 2024, suited astronauts climbed through a full-scale Starship lander mock-up, checking the airlock, the handrails, and the elevator meant to lower them to the surface. Blue Origin is building the other one, called Blue Moon. Both are enormous, ambitious, and still deep in development. So the shape of Artemis III bends around whichever one crosses the finish line first. And the suit is its own quiet question mark. The Artemis moon suit is the Axiom U from Axiom Space, built for real mobility, a wider range of body sizes, and actual geology work on the surface. By early 2026, NASA reported it had passed a major review and logged over 850 hours of pressurized testing with people inside. Good progress. But even the suit, the most personal piece of the whole landing, is one more outside system that has to plug into everything else and pass its own gate before anyone goes down. So step back and look at what is really being asked. So what do you think? Is building the moon program out of competing private pieces the smart, modern way to do it? Or did NASA trade Apollo's simplicity for a gamble it cannot fully control? Drop your take in the comments and let me know which camp you are in.